Hi there, in this video I'm going to do a past exam paper question on coordinate geometry. So let's take a look at this question. Question number 10. The line L1 passes through the point A with coordinates 2 and 5 and has gradient minus half. In part A, find an equation of L1, giving your answer in the form y equals mx plus c. So let's see how we can solve this problem. Let's get back to the paper and pen. So for 10 part A, we have this coordinate for A, 2 and 5, and we have the gradient, so we denote gradient by using the letter m. M is minus half. Now to work out the equation of L1, we can use this formula. So the equation of the line L1, and we can use this formula y minus y1, and that is m into x minus x1. Now, looking at this formula, x1 and y1 are the coordinates of the points where the line passes through. So the line L1 passes through A. A has coordinates 2 and 5. So x1 and y1, let's make a note, 2 and 5. As for m, m is the gradient of this line. M is minus half. So let's plug in the data into the formula to give us y minus y1. Y1 is 5. That is equal to m replaced by minus half, open a bracket, x minus, and x1 replaced by 2. Now let's get rid of the brackets. On the left we'll have y minus 5. That is equal to minus half times x is minus half x. Minus half times minus 2 is plus 1, so be careful with your multiplication. And if I therefore take the minus 5 to the right hand side, we're going to end up with y. Y is minus half x. 1 plus the 5 is 6. So that should be the solution to part A. So let's go back to the screenshot. So in part A, we need our answer in the form y equals mx plus c. Back to the paper and pen, and we have our answer in its required form. Back to the question. Now, the point B has coordinates. So B has coordinates minus 2 and 7. Show that B lies on L1. So let's think about this part of the problem. Let's get back to the paper and pen. Now we have the equation of L1, so let's write the equation. Y is minus half x plus 6, so that's the equation of L1. So in order to prove whether this point lies on the line, let me put the x coordinate into the given equation and let's check whether we get the corresponding y coordinate of 7. So let me put x equals minus 2. And let's see whether the answer corresponds to 7. So y will be minus half x replaced by minus 2 plus 6. And as you can see, the 2 will cancel with the 2 once. And minus 1 times another minus 1 is plus 1. Plus 6 is 7. So when you replace x equals minus 2 into the equation of L1, we had the corresponding y coordinate of 7. And this means that B lies on L1. So that should be the solution to part B. Let's go back to the screenshot. So we have another couple of parts to do. For part C is find the length. So find the length of AB, giving your answer in the form k root 5, where k is an integer. Now, from the question, the coordinate of A is 2 and 5, and we have the coordinates of B. B is given by the coordinates minus 2 and 7, so please bear those coordinates in mind when solving this particular part C. Back to the paper and pen. So I've noted the coordinates of A and B. Let me name one of them, x1 and y1. So I'm going to name the coordinate A as x1, y1. I'm going to name the coordinate B x2, y2. And the reason for this is there is a formula to work out the length or the distance AB. So to work out the length or the distance AB, here's the formula. The formula is the square root, and it's the square root of x1 minus x2 squared plus y1 minus y2 squared. So it's the square root of the difference in x coordinates squared plus the difference in the corresponding y coordinate squared. So let's plug in the data. So when we substitute in the data, we'll have the square root of. Now x1 corresponds to 2, so 2 minus x2, that corresponds to minus 2 squared. Let me lengthen this root, plus y1 corresponds to 5, minus, and y2, that corresponds to 7 squared. So if we go the extra step, so let's simplify further, we'll have the square root of 2 minus minus 2, 2 minus minus 2 is 4, 4 squared is 16, plus 5 minus 7, 5 minus 7 is minus 2 squared is 4. So when we sum this, 16 plus 4 is 20, so it's the root of 20. However, we can use one of the rules for surds in order to simplify this. And the rule that I'm referring to is, if I have the root of AB, that is the same as the root of A times the root of B. So I can use this rule for surds in order to break down root 20. So root 20, that being the same as root 4 times root 5. And since root 4 is 2, it's 2 root 5, and it's 2 root 5 units. So that should be the solution to part C. So part D, the point C lies on L1 and has x coordinate equal to P. The length of AC is 5 units. And in part D, show that P satisfies P squared minus 4P minus 16 is equal to 0. So let's go back to the paper and pen. So we have this point C and it has an x coordinate of P. So this is the x coordinates for this point C. Now we have the length of AC. The length of AC given is 5 units. And we need to show that quadratic. Now, we need to use the length formula since we have the length given as 5 units. And we have the x coordinate of C. The x coordinate of C is P, but we need the corresponding y coordinates. Now, if we go back to the question did say that the point C lies on L1. So we can use the equation of L1 and the solution of which we found in part A. So if we go back to the paper and pen, we found the solution to L1. Here is the solution that we had for part A. We can use this solution by putting the x coordinate of C in to work out the y coordinate of C. So let's do that. So y is minus half x plus 6, so minus half x plus 6, so that is L1, and let's put the x coordinate of P into this in order to find the corresponding y coordinates. So x is P, so y will be minus half x is P plus 6, so let me leave it as minus P over 2 plus 6. So that is the corresponding y coordinates. Now we have the length of AC, that being 5 units, and we can use this length formula in order to help us derive that quadratic that they want. So this point C has an x coordinate of P, and the y coordinate we had as minus P over 2 plus 6. So I'm going to call this x1 and y1 when it comes to applying this length formula. And since we have the length of AC, coordinate of A is 2 and 5. So let's note down that 2 and 5. Let me call that x2 and y2 when it comes to the length formula. So let's find the length of AC. So the length of AC, so remember the formula is square roots, so square root of x1 minus x2 squared plus y1 minus y2 squared. And when I substitute the data, we'll have the square root of, so let's have a look. So let's open up a nice big bracket. x1 corresponds to P, minus x2 is 2 squared, plus, and y1 is minus P over 2, so minus P over 2 plus 6, so here's our y1, minus, so a minus, y2 is 5. Let's close that bracket and square. So let's complete this by including that square root. So let's go one stage further. Let's multiply these brackets. Let's see what we're going to get. So in this case, we're going to have square roots. So I'm going to have from the first term P minus 2, so P minus 2 squared to expand, plus, and from the second bracket, let's be careful, I have a minus P over 2 from here, so minus P over 2, and plus 6 minus 5 is plus 1, and we need to square that term, don't forget. So let's go to the extra stage. So in this case, let's multiply out. So we'll have the square root of P minus 2 squared when multiplied is P squared minus 4P plus 4. So be careful with your expansion. And when we multiply this bracket out, we'll have minus P over 2 squared, and minus P over 2 squared is plus P squared over 4. And in the middle, we'll have 2 times minus P over 2 times 1. So 2 times minus P over 2 is minus P, times 1 is minus P, plus, and 1 squared, which is 1. So be careful when you multiply this term as well as this term. So this is a result of multiplying out these two brackets. And if we go one extra step to simplify, we'll have the square root of, so let's have a look, P squared plus P squared over 4 is 5P squared over 4. Minus 4P minus P is minus 5P. And 4 plus the 1 is 5. So that is what we have for the length of AC. Now, if we go back to the question, we have the length of AC and that is given as 5 units. So back to the paper and pen. So let's equate this to 5. So since AC is equal to 5, so let's equate this term. So the square root of 5P squared over 4 minus 5P plus 5. Let's equate that to the length given, which is 5. Now, to get rid of this square root, we need to square both sides. So by squaring both sides, and if I square both sides, the left hand side will be 5P squared over 4 minus 5P plus 5. And when I square the right hand side, 5 squared is 25. Now, I don't like this 4. I don't like fractions. Let me get rid of this 4. So to get rid of this 4, let's multiply throughout by 4. So if I multiply every term by 4, we're going to have 5p squared minus 5p times 4 is 20p. 5 times 4 is 20. That is equal to 25 times 4, 100. And let's form a quadratic. So if I bring this 100 to the left hand side, we're going to end up with 5p squared minus 20p. 20 minus 100 is minus 80, and that is equal to 0. Now we can simplify this quadratic. We can simplify by dividing by 5. So if I divide by 5, so dividing by 5 every single term, even terms on the right hand side, 5p squared over 5 is p squared minus 20p divided by 5 is 4p minus 80 divided by 5 is minus 16, and that is equal to 0. So if we go back to the screenshot, that is the quadratic that we need to show. So we need to show that quadratic p squared minus 4p minus 16 is equal to 0. And if we go back to the paper and pen, we have that particular quadratic. So that solves part D, and that solves the entire question. So I hope you found this video helpful. I hope you enjoyed the video. If you did enjoy the video, a like rating is very much appreciated. Now, if you're unfamiliar with the concepts used to solve this question, I will provide links to the appropriate videos in the description below. Other than that, I hope you enjoyed this video, and I hope to see you again. Thank you.